Hi. So for question 3, we're told, given that the point A has position vector 4i minus 5j, and the point B has position vector minus 5i minus 2j, find the vector from A to B. Okay, so for part A of this question, like any other maths question, I would recommend you to draw a nice big schematic of the question. Okay, so as you can see here, I've got my origin, and I've arbitrarily drawn this just in the middle of the page, and from this I have drawn the positions of A and B relative to my origin. Okay, so what I can now do is I can label in the vectors from O to A and O to B respectively. Okay, so from O to A, and I'm just going to write it in column form, is 4i minus 5j. Okay, and the same for O to B, which is minus 5i minus 2j. Okay, again in column form. It doesn't matter if you're working in column form or you're working in I or j notation. I just prefer column form. Okay, so you'll get the same answer either way. So what are we asked to find in this question? We've been asked to find the vector from A to B. Okay, so you need to ask yourself the question, how do you get from A to B? Well, you need to go back along this vector here and then forward along this vector here. Okay, so I'm just going to write here A to B equals from A to O, which, bearing in mind, is the opposite direction of O to A, just keep that in mind, and then we need to plus O to B. Okay, so A to O, just like I said before, is the opposite direction to O to A, so we need to give this a negative sign here, minus 4i minus 5j. Okay, that negative sign is just to show that we're going back along the original direction of this vector. Okay, and then to this we are adding the vector from O to B, which is minus 5i minus 2j. Okay, so if you compute this, minus 4 add minus 5 is minus 9, and then minus 5, which is plus 5, add minus 2 is positive 3. Okay, so that's the answer there for part A. The vector A to B is minus 9i plus 3j. Okay, so we can also say this is minus 9i plus 3j. Okay, so now for part B, we've been asked to find the magnitude of this vector A to B. Okay, so this is simply going to be finding the length of this vector. Okay, so to find the length, we can split this vector up into its constituent components, I and j, and we know the I component is 9 and the j component is 3. Okay, and so here we're just talking about the magnitude of each of these components, and now we can simply do Pythagoras, because we have a right angle triangle, to find the hypotenuse. Okay, so what I'm going to say here is magnitude of A to B is equal to the square root of 9 squared plus 3 squared. Okay, so if you work that out, 9 squared is 81, 3 squared is 9, 81 plus 9 is 90, so this is the square root of 90. Okay, what I can do now is I can express 90 as a product of its two factors, 9 and 10, and now I know the square root of 9 is simply 3. Okay, so I know the magnitude of the vector A to B is 3 root 10. Okay, and that brings us to the end of this tutorial. So thank you very much for watching, and if you're having trouble with vectors, what I suggest you do is have a look at the link in the description below, and it will take you to a few different video tutorials where you can brush up on your vectors and even practice exam questions as well. So don't forget to like, comment and subscribe to this video, subscribe to the channel. Thank you very much.